Welcome to the thermodynamics lab. Today we are going to perform an experiment on nozzle performance study unit. This apparatus helps students to determine the critical pressure ratio, efficiency of the nozzle and the nozzle thrust. Furthermore, this apparatus helps students to determine the relationship between the nozzle dia and all these nozzle performance characteristics. Here is the experimental setup of nozzle performance study system. The apparatus consists of the following parts. This is the valve used to set the back pressure. Here is the rotameter, which basically measures the volume flow rate of the discharge air. Here you can see the units of this rotameter. It can measure the volume flow rate in liter per minute as well as gallon per minute. Here inlet pressure indicator is mounted, from which you can see the value of inlet pressure air. Here is the inlet temperature indicator, then flexion pipe force indicator, temperature outlet indicator and the pressure outlet indicator. From you can see the values of inlet temperature air, force, outlet temperature air and the outlet pressure of the discharge air respectively. Here is the main switch of this apparatus, from where you can switch on the electrical supplies. This is the process diagram of this nozzle performance. This is the dial screw gauge. From this gauge you can set the distance between the nozzle and the baffle plate. Beneath this test chamber, 3 different sensors are mounted. The first sensor is the distance sensor, which measures the bending of the pipe, which basically measures the force. This is the outlet pressure sensor, and the third sensor is the outlet temperature sensor. Here you can see the inside view of the test chamber. Here you can see that this is the converging nozzle, this is the baffle plate, and this pipe is the flexion pipe, and these are the sensors: temperature sensors, pressure sensor and distance sensor. Now what happens inside the test chamber? Air enters in this pipe and pass through the converging nozzle. The converging nozzle increases the velocity of the air. The high velocity air strikes the baffle plate, which is mounted on the flexion pipe. The high velocity air applies force on this flexion pipe, and this flexion pipe starts to bend. When this flexion pipe bends enough, it strikes this sensor, and this sensor basically senses the applied force and displayed on this indicator. So to start the experiment, first of all, insert the nozzle inside this test chamber and then close this test chamber. Then switch on the electrical supply. Then open this compressor valve. Adjust the inlet pressure by using this knob. This is basically the inlet air pressure controller. Now set the pressure to 5.6 bar and increase the back pressure by using this valve, which basically increases the outlet pressure and the volume flow rate. Now repeat this procedure 3 to 5 times and noted all the values required to calculate the experiments, which is pressure in, temperature in, force, temperature out and pressure out, and volume flow rate.